privilege to welcome you all for this national webinar on an introductory concept of fluid dynamics. It's my duty to thank our Honorable Chairman, Line Dr. K.S. Rangasamy MJF, Vice Chairman Mr. R. Srinivasan, Executive Directors Mrs. Kavita Srinivasan for their continuous support in all our endeavors. I feel proud to welcome our resource person, Dr.M.Kayalvizhi, who is going to enlighten us with her wide knowledge of fluid dynamics. Welcome you, ma'am. Next, I cordially welcome the enthusiastic participants from all over India who have gathered here through online. I am very delighted in welcoming my colleagues, friends, and my students community. Once again, I welcome you all, and I assure you that this webinar will fulfill your intellectual needs in the area of fluid dynamics. Thank you.
Hello, ma'am. Shall I start?
You can start, ma'am.
Yeah. First of all, I would like to thank the organizing committee and particularly the principal of KSR College and the HOD of the department, mathematics department, and all the participants, everyone, for giving this wonderful opportunity to share my views in fluid dynamics. Just I will present my, yeah.
Ma'am, excuse me, ma'am.
Yeah. Yes, ma'am.
Sunja will introduce you. After that, you can start, ma'am. Sorry, ma'am.
It's okay, ma'am.
Okay. Sunja, you can start your introduction.
Good morning to everyone. I felt very much glad to give guest introduction at this valuable occasion. Our beloved guest, Dr. M. Kayalvizhi ma'am, completed her schooling in Tarapuram, BSc Mathematics in Vellala College for Women, Erode. Then she had completed her MSc, MPhil and PhD in the consecutive years at Bharatiya University, Coimbatore. She completed her PhD in the title of Studies on Nonlinear Forced Convection Flow over a Stretching Surface with Thermal Radiation Effects. Her field of interests were heat and mass transfer, MHD, boundary layer theory, numerical methods, finite element techniques, mathematical methods. Awarded as Research Fellowship in Sciences for meritorious students under UGC scheme during Feb 2010 to August 2011. She had published nearly 12 papers, presented 9 research papers in conferences, and attended nearly 8 workshops. She had given research talks at some universities and FTPs. Got selected in UPSC Group A Gazetted Officer, Central Government Polytechnic, Daman in 2016. Ma'am has good computational skills like Fortran, C, LaTeX, Mathematica, MATLAB. We are really lucky to have such eminent person as today's guest. Thank you for giving me this opportunity to tell about multi-talented women. Thank you.
Thank you, ma'am. Next, I hand over the session to our resource person. Please, you can start your presentation, ma'am.
Yes, thank you, ma'am. Yeah. Good morning to one and all present here. Thank you for giving this opportunity to share my views in fluid dynamics. Before going to the concept of fluid dynamics, it has too much of applications in our day-to-day life. Ma'am, whether the audio and video clear, ma'am? The presentation is visible?
Yes, visible, ma'am.
Yes, ma'am, it is clear.
Okay, ma'am. Then, okay. First of all, I would like to explain mechanics. My mechanics, that is nothing but it deals with both stationary and moving bodies under the influence of force. It is not even a stationary particle. It is considering both stationary and moving particle. For example, a car is moving with 30 kilometer speed. After that, it stops. Then, whenever it is going in which path, with how much velocity, with how much acceleration, and where it is the destination, starting point, we are discussing all these mechanism. Then it comes under mechanics. Okay, as a branch of mechanics is there are three branch of mechanics, that is statics, kinematics, and dynamics. So first I want to explain statics. Statics is nothing but a, deals with a particle which is at steady state. Steady state means everyone will think it of there is no force, that is called the steady state. It is not like that. Here, for example, here one particle is there. We are giving the force both side, equal and opposite force. So what will happen here? Acceleration will if it is equal force, then automatically acceleration goes to zero. According to Newton's third law, force equal to mass into acceleration. When the acceleration, there is no acceleration, since it is a equal force, so automatically mass into acceleration, acceleration becomes zero, so that the net force F is equal to zero. So what happened if it is a equilibrium state? For both the force are equal, then the particle is at rest. So we can't tell whenever the particle is at rest, we can't tell there is no force is act on that body, like that we can't able to tell. Either maybe it is there is no force, otherwise two forces, two or infinite number of forces act on the particle in a equal and opposite, so that it make it in a equilibrium state. Okay, whenever we are studying all these concept, that comes under statics. So a particle which is at a steady state, that is it is at particularly rest state, then it comes under statics. So okay, yes, whenever a science that deals with both a motion of the particle. For example, in a cricketer, just he is bowling, otherwise he is hitting the ball with some velocity, some force. Okay, so if we didn't consider the force, only we are considering the path of this ball and how much acceleration it is going, in which velocity, what is the position of this ball at the end position. So motion of this ball or any system under some force, what is the motion, what are the displacement, distance, time, velocity, acceleration. If we study these concept, then it is comes under kinematics. Kinematics is nothing but kind, this word means that movement, motion. Matics is max, that is motion. Whenever a system is in motion, we are calculating. Mathematics is nothing but calculation of moving particle, that is nothing but kinematics. Okay, dynamics also the same. We study about the moving particle, but what is the difference between the kinematics and dynamics? Kinematics is nothing but when we study about the moving particle, we won't consider the cause, for what purpose, for what reason this particle is moving, under which force, how much force is given to the particle. If we didn't consider that, then it comes under kinematics. Whenever if we are considering what force, at how much force if you give, it will go sixer or a four. So the cause of the movement, that if we consider, then it comes under dynamics. So whenever we are considering the cause of the movement, then it comes under dynamics. So what is the advantage compared to kinematics? What is the advantage of dynamics? We can predict how much force if we give, then this ball goes sixer or four or only one run. So what is the path? If we give the some force, what is the path of the particle? Everything we can find out. We can easily find out with the help of the dynamics because it is nothing but we are calculating the force also. Okay, prediction. It will gives the prediction of the particle. We can predict the motion of the object. Okay, we can predict the motion of the object under the force. That is the point we are using in solar system. We can predict the motion of the plants, at which force, which acceleration, which velocity it is moving, so that it won't hit another plant. Whether there is a possibility is there. So we can predict the velocity and acceleration and the movement of the plant in a solar system. That is only main important in a dynamics. So the compared to statics kinematics, dynamics having day to day up to day application, because this is the reason we can predict the movement of the particle, we can predict the motion of the system. Accordingly, you can use the application. Okay, before that I want to tell, uh, you now you get some idea about the dynamics. Okay, so dynamics is nothing but a particle which is in motion. We consider both the cause of the particle and also motion of the particle. Okay, matter. Matter is nothing, it is a tiny particles. It is based on, for example, you consider a water. Okay, water, it is it is a combination of many molecules, particularly H2O, that is two hydrogen and one oxygen. This hydrogen is an atom. Each atom has electrons, protons. Okay, so basically nucleus, we are having a nucleus. In that nucleus, protons and neutrons is there. In a orbit, electrons are moving here and there. Hydrogen atomic number, you know very well, it is 2. So 2 electrons are moving in the orbit. This is called atom. So two hydrogen atoms and one oxygen atoms, this combination gives the molecule, that is H2O molecule. So protons and neutrons combination, nucleus and electrons, this protons neutrons electrons combination gives the atom, that is hydrogen and oxygen. Two hydrogen and one oxygen, this combination gives the molecules. Okay, this water molecule, too much of more than one molecules, that is combination of molecules, it will gives the water. That water is a matter or a system or a body. Okay, so matter is nothing but the combination of molecules. Molecules is nothing but the one or two atoms are combined. Okay, what are the types of matter? Next point: solid, liquid and gas. Okay, solid. These molecules, the intermolecular force is very high. Intermolecular force meaning is force between the molecules. Here, force between the molecules is very high. So, the molecules are in higher attraction here. Higher attraction. So, it is tightly packed. It has a definite safe. Okay. Whenever if you consider in a liquid, here, the molecules are not tightly packed because the force between the molecules is less compared to solid. So it will move here and there. That is only enough. For example, liquid means water or any oil. Oil also a liquid only. Okay, these and all can flow, so it can able to flow, but it can't able to flow. It can either broke, if you give some force, some pressure, it will broke or it will bend. But if you consider a liquid, it won't broke and bend, it will flow. If you are giving little pressure, it will move from one place to another place. Just tilt, if you tilt a water, it will flow in a ground. That's all. If you consider a gas, the intermolecular force is very, very less. It is loosely packed. So, a very small force, very small pressure, if you give, that is enough, it will move from here to there. Okay. So the solid, liquid and gas, this is the main important difference based on the intermolecular force, that is force between the molecules. Okay. Now my point. What is fluid? When everyone will think fluid. Okay, fluid means liquid. Liquid is a fluid. Like that everyone will think. But you understand the point, not only a liquid and also gas, both are called as a fluid. Liquid is one type of fluid and gas is one type of fluid. Okay. And then what is the definition of fluid? Why you are telling gas is also a fluid? Here, fluid is nothing but a material which can able to flow. Which a material which can able to flow is called as a fluid. So next point, with what material you can tell it as it can able to flow? If you give a very less force, very applied force, very small, however small the force may be, then also the particle is ready to flow. Then that type of material is called a fluid. A material which is flow is called as a fluid. That is only I am telling. If very small force if you give also it can able to flow, then it is called as a fluid. So gas is also a fluid. If you give a very small force, then also it can able to flow. So solid is not a fluid, but if you think it of liquid and gas, both are comes under a fluid category. Yes. Yeah. So basic definition of fluid dynamics now we completed. What fluid is a substance which can able to flow. Dynamics is nothing but a study of a motion and its cause means any force, either pressure force or torque force, any force. Because of that force the particle is moving. We are studying about these type these system, that is comes under fluid dynamics. So a science that deals with both study of a motion of a fluid under some external or internal force, it comes under fluid dynamics. Okay. Now I told liquid is also a fluid, gas is also a fluid. So liquid is what type of fluid, gas is what type of fluid? It is, we are having a separation. Fluid is a compressible fluid, incompressible fluid, viscous fluid and also inviscid fluid. Okay. First I want to tell about the compressible fluid. In the word itself you can understand the meaning. Compressible, that is compress. If you giving the compressible pressure, if you are compressing, if you are giving the pressure, then also the density won't change, then it is incompressible. If the density change, then it is compressible. So for example, here you take a gas. For in a gas cylinder, if you are giving the, hello, hello,
மேம் சொல்லுங்க
uh,
மேம்.
nothing ma'am, actually in my system uh, charge is current cut ஆயிருச்சுங்க மேம்.
ஸோ கேன் யூ யூஸ் யுவர் மொபைல்?
Shall I come in a mobile ma'am?
ம், ஓகே. ஓகே,
Just for
கண்டினியூ.
1 minute ma'am. 1 minute ma'am. Yeah.
ஓகே, ஓகே, கண்டினியூ. ம்.
ஹலோ. சொல்லு ராஜ். ஆஹா, போக மாட்டேங்குது. கட் ஆயிருச்சுன்னாங்கல்ல. ஹலோ. அதுதான் எங்களுக்கு ஏதோ பவர் கட் ஆயிடுச்சுன்னு லேப்.
Hello, friends, and extremely sorry for this issue. I didn't expect this one. Hello.
You're audible, ma'am.
Yeah, my whether you can hearable my voice. Actually, I sent my PowerPoint to the mail. Whether you got it, ma'am?
Ma'am, no, ma'am.
Ma'am, to Sindhuja madam, I sent the mail, the PowerPoint, ma'am. Hello, Sindhuja ma'am. Hello, Sindhuja ma'am, Rajita ma'am.
Ma'am, yeah, ma'am, mail received, ma'am. Wait, ma'am, it's
Yeah,
downloading.
okay, no issue.
Okay.
Extremely sorry, friends. Actually, in my area, the power shut down. Full night, too much of rain, so that power shut down. In my laptop, I had the charger, but it it is continued only half an hour. I thought before the completion of the charge, I need to complete like that. I thought, but unfortunately, shut down. Till now, the power is not coming. That is the big issue. Extremely sorry, audience. Okay. Just shall I explain, ma'am, otherwise, without PowerPoint?
Yes, ma'am, you can start, ma'am.
Mm. Okay, ma'am. So I think I stopped at the type of fluids, that is compressible fluid, incompressible fluid. There I stopped. Hello.
Yes, ma'am, you're audible. You can start.
Okay, fine. Thank you. Okay,
Okay,
fine.
ma'am.
Compressible fluid, incompressible fluid. That is the main difference in the fluid, types of fluid. Compressible, in the word itself, you can understand. You can compress the fluid. Whenever you are giving the pressure brings the change in density. It is nothing but compressible fluid. What is the meaning? If you are giving a particular pressure, so that the particle distance between the particle will be reduced, so automatically the intermolecular force will be increased. Okay, so all the particles is come together. If you are giving the pressure, then the particles is come together, so it will become tightly packed, so automatically density will increase. So whenever pressure increases, so density will increase. That is nothing but a compressible fluid. The best example for a compressible fluid is gas. When you are giving the pressure in a gas, so the distance between the gas molecules is high. So if you are giving the pressure, both the molecules is come together, so that automatically density will increase. That is, it is behave like a liquid. Okay. For example, you take a gas cylinder. In a gas cylinder, normally how much amount of gas you can put it? For example, 15.3 to 16.2, like that kg gas you can fill it. If you giving the high pressure, then also you can able to uh, add too much of gas in that cylinder. So pressure increases brings the change in density. If it is possible, then it comes under compressible fluid. The best example is gas. Next, I can tell it about the here liquid. For example, you take a 1 liter water bottle. In a 1 liter water bottle, if you are giving too much pressure, then also you can't able to pour in that 1 liter water bottle 2 liter water. 1 liter water bottle can able to capable to occupy only 1 liter water. However, pressure if you give, it won't change. That is the point. If the pressure brings, there is no change in density. That is nothing but a liquid. Okay. However, pressure if you give, the force between the molecules, it won't change. So automatically there is no change in density. That comes under incompressible fluid. Then viscous fluid. Viscous means viscosity. Viscosity, that is nothing but stickiness property. Whenever any fluid if you take, there is a stickiness. Best example is honey, or for example some oil, crude, any oil, petroleum. Blood is also a viscosity, having some viscosity property. Okay, these and are having a stickiness property. So there is a friction. Frictional effects are significant. You are having a frictional, when you touch the fluid, you can get some frictional force. Okay, it is significant in a viscous fluid. Whenever there is a viscosity, then it comes, yeah, that is nothing but a viscous fluid. Inviscid fluid, in the word itself you can understand, there is no viscosity, that is stickiness property. There is no stickiness property, then it comes under inviscid fluid. For example, here I am putting a yeah, in the if you are considering whether if I expand, then it is also visible, ma'am, for others. Hello.
Yes,
Hello,
ma'am,
Rajita
visible.
ma'am. If I am expanding
Visible,
the,
ma'am.
yeah, if I am touching the screen, then it is visible. Okay, in this plate here, if you see the next power in that PowerPoint, the same screen, the viscous flow region, that is near to the plate. Near to the plate, there is a friction, there is a stickiness, it is boundary of the plate. That region is a viscous flow region. Whenever nearer to the boundary, then you will get a viscosity property. If we move away from the boundary, then it comes to the inviscid region. So in the next ma'am, next slide, ma'am. Yeah, in the next slide here, in the first is gas. It is a compressible fluid. If however, if you compress, you can it is possible to compress. If water is an incompressible fluid, you can't compress it. Here in the down, I put high viscosity, low viscosity profile, velocity profile. Here, if you see at the boundary, in the high viscosity, at the boundary, you are getting very less velocity. Why? Whenever at the boundary, the stickiness property is there, so the fluid automatically stick at the boundary, so fluid motion is less, so automatically velocity will reduce. At the center, what will happen? It will move freely without boundary, without friction problem, without friction, it will move easily. So at the center, it is high viscosity property fluid. What happened at the center alone, the velocity will be high. At the boundary, the velocity is low. That is, there is a friction. If you consider a low velocity, each and every particle having the same velocity profile. Next, water, olive oil, honey. If you consider these, water is a inviscid fluid. Viscosity property is less. Consider olive oil, it is a medium viscosity having. Honey, a high viscosity, it is having a high viscosity. Ma'am, next. Next, the important point. Whenever you are seeing any system, you need to observe the flow of the material, that is flow of the atom, flow of the molecules. Then only you can understand what is the what is the behavior of the material, what is the behavior of the fluid, you can understand. The point is, for example, if you are preparing the food, the rice is cooked or not, how you understand? You take one rice and you check it whether it is cooked. If it is cooked, the whole rice will be cooked, you can understand. So one particle, if you are taking and checking the velocity, acceleration, the motion, everything, it will give the whole system behavior, it will give the behavior or flow motion of the whole system. That is the point here, microscopic approach. Whenever, if you are considering a fluid motion, if you take a single fluid particle and you follow what are the behavior of the flow motion, what are the behavior, if you consider, it is gives the total all the fluid particles behavior. That approach is called microscopic approach, that is statistical approach. Next, macroscopic approach. Macroscopic means each and every particle we need to consider. That is nothing but to find the flow of the motion, you need to follow the macroscopic volume element, then you can observe the fluid motion. Okay, so here you see the microscopic scale pressure is determined by the interaction of individual gas molecules. Here, if you see the pressure gauge, each molecule, one molecule is touch the next molecule so that the pressure occurs. Similarly, each molecule collision, due to the collision, you will get the pressure. This pressure you can find out using the microscopic scale. Okay, if in a macroscopic scale, what you can do, just you attach the pressure gauge so that you can see each and every molecule's final pressure gauge, you can find out. Got the point? Next picture, ma'am. So each particle, what you can do, you need to find out the microscopic or macroscopic approach, which approach you can finalize. Ma'am, next slide, ma'am. Ma'am, Rajita ma'am, next slide. Yes. Types of forces: surface force, body force. Surface force is a force which influence only on the surface. If you are having any force only on the surface, then it comes under a surface force. Surface force is always directly proportional to the surface area of the body. If you consider the body force, if the point of application will be only exterior of the body, but the influence felt throughout the body. Throughout the body, you can observe the influence of the force. For example, the simple example is gravitational force. Whenever the gravitational force happen, what will be happened? The full apple comes down, because only the force is only the outside area, but the influence inside each and every particle, so the full particle comes down. The simple point is pressure force, viscous force, these and all only a surface force, only it acts on the surface. But if you consider a gravitational force or electromagnetic force, these and all affect throughout the body. Next is stress. Stress is nothing but force per unit area. Actually, there are two components, that is tangential components and perpendicular component. Tangential component stress is nothing but shearing stress. The perpendicular component, that is nothing but normal stress. So, whenever you are giving the pressure in the normal, what will happen? It is perpendicular. The pressure is perpendicular to the surface. That is normal stress. If the body is rest, that is system is rest, for example, in a plate the fluid is moving, the plate is at rest, then what about the tangential force? That is the tangential force, that is nothing but shearing stress. If the plate is at rest, then shearing stress automatically it is goes to zero, that is you will get the zero shearing stress. Was next. So now we studied what are the forces act on the body, what are the types of fluids are there, and also I want to tell about real fluid and ideal fluid. What is mean by real fluid, ideal fluid? Ideal fluid is nothing but incompressible inviscid fluid is called as a ideal fluid, but it is you can't able to see this type of ideal fluid because a fluid which is incompressible and also inviscid, it is a rare fluid. Okay, normally we will see a real fluid, that is viscosity and compressibility both are having. For example, gas, it is having a viscosity and compressibility, that is called as a real fluid. Ma'am, next slide, ma'am. Next, types of fluid flows. So now we know the fluid, what and all force will act on the fluid, what and all approach, microscope approach, macroscope approach, like that approaches are there to study the fluid flow. Now, what are the types of fluid flows are there? We need to see. First is internal and external flow. Internal flow is nothing but a fluid flow inside the pipe. Water, for example, in the next picture, water is flow inside the pipes, that is internal flow. The same, for example, in the first picture, external flow, as for example, if in a boat, you consider a boat is going in a water. What happened? The water and all is outside the boat. Okay, this fluid is outside area of the boat, and also it will give a force to move the boat front. Okay, in a boundary there is a friction. Due to the friction, it will help to move forward. This fluid, that is water, is a outside of the boat, that is comes in a external flow. And one more, for example, if you are throwing a ball, the last picture, air flow over a ball. Throughout the ball, you are having a airflow. This airflow also help to move the ball forward or some backward, depending on the direction of the air. For example, if you are having too much air, for example, cyclone, like that, too much air if it is there, then the ball will move very fast. If you are giving very little velocity, very little force also, but because of the air in the surrounding, in the area, what will happen? It will move very fast. And the direction also depending on the flow direction of the flow direction of the air. Atmospheric air direction, it also depend. For example, if you are giving a certain force, compared to that force, direction of the surrounding air that is high, then that direction only the ball will move. Okay, so that is the point. So the surrounding area air also affect the ball movement of the ball and the direction displacement of the ball. So that only sometimes in cricket, if you are putting a 6 or 4, we will think it will go like 6, but due to some circumstance that it will affect the movement of the ball, the displacement, it will affect. Ma'am, next slide, ma'am. Yeah, steady and unsteady flow. It is depending on the velocity of the fluid. Here, for example, you see the first and the second. Hello?
Ma'am, excuse me, ma'am, slide is not visible, ma'am.
Ma'am, Rajita ma'am only putting the slide, ma'am. I can see the slide.
Ma'am, slide not visible here, ma'am.
Ma'am, pin my name, ma'am.
Ma'am, you pin Rajita ma'am so that you can see the slide, ma'am, because I can able to see the slide. By seeing the slide only, I am explaining. Hello, ma'am. Whether now you can see the slide, ma'am?
No, ma'am.
Okay. Rajita ma'am.
Ma'am, you can continue, ma'am. It is visible.
Okay, ma'am. Thank you. Fine, because already time's late. Steady and unsteady flow. The point you understand that whenever a fluid, because of the fluid velocity is independent of time. That is, for example, water is going in a particular velocity in a particular time, in a same velocity. For example, you are moving in a 5 kilometers. Hello. Yeah, thank you. For example, if you are moving with a uniform speed, what is mean by uniform speed? You are that is the velocity depending on this time, it is changing in a uniformly. That is going, walking or jogging in a uniform speed. So the change in velocity with respect to time, that is equal to zero. There is no change in velocity, that is uniform velocity. If it is moving, then it comes under steady motion. Many of the students what will think steady means it is in okay, the velocity, there is no velocity, it is going steady. That is uniform velocity, the velocity throughout the fluid flow, it is constant, there is no change in velocity. That is independent of time. If after 5 times or 5 minutes also the same velocity, after 10 minutes also you will get the same velocity. That is steady velocity. Unsteady velocity means it is uncertain. That is the velocity will be changed with respect to the time. That is the first figure. If you see the first figure, the fluid flow, that is depending on the time, the speed velocity will be changed. But in the second figure, if you see, the velocity won't be changed. Each particle after sometimes you will get the same velocity. That is for example, river water. In the next figure you can see, ma'am, next PowerPoint. Here laminar flow also sometimes we can say tell it as steady only, because here laminar flow, first layer, second layer, you need to see in a broad minded way. Whenever laminar flow, the first layer, that is nearer to the boundary, and next layer at the center of the layer, and next, in each layer the velocity is constant. That is constant meaning is what? If after half an hour, after 1 hour also, the velocity remains the same, there is no change in velocity. That is the laminar flow. Okay, next, turbulent flow. Laminar flow, the best example is, if you consider a pipe, in a pipe water is flowing inside the pipe, that is a best example for the laminar flow. In a turbulent flow, for example, here in a seawater, after a second also there exists a turbulence, the velocity will change automatically. Every instant the velocity will change. That is nothing but a turbulent flow. Next is transitional flow, that is nothing but it is in between laminar and turbulent. And that is some more time it is uniform, after sometimes it will be changed. Like that it will happen. The best example we can tell it as incense stick burning. Incense stick, if it is burned, or cigarette burning, anything, if it is burned, you see the airflow, there is a circular motion, it is not in uniform way, there is a turbulence flow is happened in the air. Ma'am, next slide, ma'am. Yeah, and the pipe flow, it is laminar. Next one is incense stick burning. Here the turbulency will occur. Ma'am, next slide, ma'am. Natural and forced flow. It is nothing but this is important topic in a fluid flow. Okay, what is natural, what is forced? Forced, you know very well, whenever you are giving some pressure or some force, so that the fluid flow will happen. For example, pumping also the example for forced flow, or fan, using the fan. We are for example, in a mobile phone nowadays we are using, inside the mobile phone chip is there. Yes, after sometimes what happened, the chip will be heat, so that your phone automatically will be heated. But after half an hour or 1 hour, automatically it is cooling. Why? How it is cooling? If it is continuously, if it is hot, then mobile will be burned. But it is not happened. What happened in between? After sometimes the mobile is heated inside the chip. If it is outside the chip, you can use fan so that the chip will be cool. It is not at all a matter. But natural flow, that is only the forced flow using fan or pump, cooling particles, cooling the system, that is comes under forced flow, sorry, natural flow. Heating we can reduce it, otherwise fluid flow is happened. Next, forced flow. Forced flow, yeah, that is sorry, forced flow is based on the pumping or um, what fan, that and all comes under forced flow. Next, I want to tell about natural flow. What is happened in the natural flow? Here you see the second figure, that is vertically I put the chip. Normally what will happen, the air is going nearer to the chip, the cool air comes nearer to the chip. Then what will happen, the cool air, when heated, it is going nearer to the hot chip, then automatically the cool air become heat. Whenever the cool air become heat, then the intermolecular force between the molecules, it will break. So the force, intermolecular force between the molecules, that is atoms, it will break. So automatically the force is break, then density will reduce. Whenever density will reduce, less than particles will move upwards. So automatically it is cooling. The heat will be changed. So heated force is reduced. Now density will reduce. So less than particles will move upwards. So higher, automatically the hot particles will move up. Then here, what happened in the back side? Similarly, the cool air is there. That once again it comes nearer to the hot chip. So automatically same procedure. Intermolecular force will reduce, density will reduce, less dense particle will move up. So the surrounding air continuously heated, but the same time the chip becomes cool, because the chip having the temperature hot, that thermal energy, it will it will spread to the nearer air molecules. So it automatically, this hot chip energy, that is thermal energy, will be reduced. This process will continue until both the chip and the air both are having the equal temperature, equilibrium position. Always a temperature difference, that is heat will transfer from high temperature to low temperature. This process will continue only both the higher temperature particle and the lower temperature particle both will have a same temperature, that is equilibrium temperature, until the process will continue. So automatically what will happen, the chip will be cool because of this air, cool air. So the temperature difference will occur. Finally both will have a same temperature. Similarly, when you boil the water, what will happen, the here, at the down of the what, some vessel, okay, down some particles are there. These particles first heated because of the fire. So this heated particles, automatically intermolecular force, what will happen, it will broke. So density will reduce. So density will reduce, automatically it will move up. So upper, the less dense particles, that is cool particles, that will come down, because dense particles automatically will come down. So whenever it will come down, once again it is heated, so density reduce, then it will go up. So there exists a circulation between the higher dense particles to the lower dense particles. This circulation is nothing but the buoyancy effect. Whenever, if you are seeing the buoyancy effect, it is very helpful in the fluid flow motion. Maximum, due to the buoyancy effect, the fluid flow will happen. Otherwise, under some force, the fluid flow will be happen. Ma'am, next slide, ma'am. Rotational and irrotational flow. Rotational flow, it is nothing but a circular motion. For example, if you are putting a stone in a water, what will happen? There exists a circulation around the particles. This circulation, that is nothing but rotation of the fluid flow. Irrotational means there is no air, it is not having the rotation in the fluid motion. If you are considering q is the velocity of the particle, then del cross q is nothing but the vorticity vector. Whenever rotation happen, then there exists a vorticity vector. Vorticity vector is nothing but a circular vector. Due to circulation, the velocity will happen. So del cross q, that is equal to 0 in a irrotational flow. Del cross q is not equal to 0 in a rotational flow. Irrotational flow, del cross q equal to 0. Ma'am, next slide, ma'am. Okay, 1, 2 and 3 dimensional flow. When you see the fluid flow, everyone will tell, okay, it is a one dimensional motion, so it is one dimensional flow like that. But it is not happen like that. For example, in the end, I put one here, one house, and the house window is there. Outside, due to the heat, the window will be cooled. Okay, actually here what will happen, the outside particles are heated, so automatically it's due to vibration, it is the temperature is moved to the next particle is vibrate and heated. After that, it will pass the temperature to the next particle. Like that, temperature is passing in a vertical direction. But if you see the horizontal direction, there is no temperature movement. So whenever particle, that is either heat is flow in one direction, or temperature, not only temperature, fluid flow in a only one direction. Even if it is a two-dimensional system, then also the change in flow occurs only in a one direction, then it is considered as a one dimensional flow. For example, a pipe flow. If you consider a pipe flow, I am putting the pipe. If you consider a pipe flow, is at the starting, the velocity is depending on both r and z. Okay, radial direction and also in the perpendicular z direction. But what happened after sometimes, only at the center the velocity is high, velocity profile having the high velocity. At the end, it will become low. But anyway, all the lines are having a uniform velocity. That is, there is no difference in the z direction. All are moving, all the particles are moving uniformly. So, V is not depending on z, V is depending only on r. So whenever the radial direction, only the flow velocity is depending. So parameter here, r and z, the parameter is reduced because it is uniform. So z we are not considering, the perpendicular direction we are not considering since it is uniform. So velocity is depending only the radial direction. So it comes under one dimensional flow. It is not a two dimensional flow. Accordingly, by each and every flow, we need to check whether it is one dimensional or two dimensional. It is depending on the fluid velocity profile. Based on the fluid velocity profile, in both the direction, if there is a difference, then only it is two dimensional. If one direction, the velocity difference is negligible, there is no difference in velocity, that is uniform velocity, then it comes under one dimensional flow. Next slide, ma'am. No slip condition. This concept is very useful in aerodynamics and also many particles which are having the boundary layer flow. Okay, for example, in the first slide, first photo, what happened, for you take that is a boat or some curved blend nose. Okay, the fluid is coming in a uniform, but at the boundary, what happened, it is sticking and it is moving in the plate velocity, or if plate or the system velocity only it is moving. Here there is no slip, no slip condition is happened. That is, at the boundary the velocity of the fluid is fully depending on the material, that is system. Whenever if you are moving out from the boundary, that is system, it is having uniform velocity. Yeah, so you see in the second picture, that is relative, that is called as a relative velocity. Whenever at the corner zero velocity, at the surface you can get the zero velocity. If you move away from the surface, you can get the relative velocity. That is, all the velocity of the fluid you will get the uniformly. Next is separation point. I need to explain the separation point. What is the separation point? Is nothing but the boundary and the fluid flow. At a one point, one stagnation point, there is a difference. After that is at that point, after the point, the velocity of the fluid is exactly the velocity of the surface. Before the point, before the separation point, the velocity of the fluid and the velocity of the system both are different. That is, that point is a separation point. Here I already told boundary layer. Boundary layer is nothing but along the boundary the fluid layer, that is nothing but boundary layer. The boundary layer, on the boundary layer the fluid velocity is exactly the velocity of the system. For example, if you take a rest plate, along the rest plate the fluid is moving, then what will happen? Above the plate, the first layer must have the zero velocity. Why? Because it is a relative velocity. The first layer of the fluid particles velocity is nothing but the surface velocity. In the surface it is rest, so the velocity of the surface is zero. So automatically the first boundary layer, the surface velocity is zero. Okay, ma'am, next slide, ma'am. Applications of fluid dynamics. Here so many applications are there: geophysics, astrophysics, biology, medicine, chemistry, physics, plant science. Ma'am, next slide. These applications I will explain in the next slides. Okay, engineering and technology, ferrofluids, immunology, daily life, we are having so many applications. Now I'm going to explain all those applications. Ma'am, next slide, ma'am. Refrigerator. In our daily life we are using refrigerator. I ask one question: why in a compressor is we are placing the compressor in the top of the refrigerator? Any reason is there? We are placing the compressor in the top freezer. What happened? Here you see, in the freezer compartment, whenever you are keeping the particles are little hot. Inside the fridge you will get a cool air. Okay, so compare that air, the particles air surrounding the particles air, that example apple, that apple surrounding air should be hot. So whenever hot particles, what will happen? Hot particles means automatically the force between the particles is less, so density will less, so automatically these particles will move up. Whenever this hot particles will move up, then because of the freezer compartment, these particles will be cool. If it is cool, automatically density will increase, so these dense particles come down. So down, what are the hot particles are there? These once again it will move up, then it is cool. After cooling, once again it comes down. There is a buoyancy effect, I already told. Due to this buoyancy effect, the particles circulation is happened from high up down to top. So automatically this heat transfer will happen. Each and every particle have the same temperature, that is what surrounding all the particles getting the same cool temperature until this circulation will happen. So it is each particle is keeping the things become cool. So this is the reason we are keeping freezer in the top. Next, ma'am. So you understand that a refrigerator fluid dynamics, that concept only mainly we are using. Next, I want to explain heat exchanger. Before heat exchanger design, you need to understand it is full and full fluid dynamics concept. Having heat exchanger is used to either cooling or heating. That is, heated particles become cool using heat exchanger. Otherwise, heated particles become cool. Heat exchanger main principle is here. One outside, inside fluid or outside fluid, two types of fluid, that is hot and cool fluid. Both fluid is separated by a solid. That is the main principle. Here one rod, like one tube is there, that is a solid. Inside the solid, cold air or cold fluid. Outside the solid tube, we are getting a either cool or hot. Now inside, if you take cool, then outside it is hot. So automatically what happen, these hot fluid circulation, due to the circulation, when it is going inside, then automatically this cool fluid become hot. So outside you will get a hot fluid is become cool, then you will get a cool fluid. So it is converse. If you are putting a cool fluid, then it will become hot. If you are putting a hot fluid, then it will become it will become heat. So this heat exchanger concept only mainly used in radiator and also AC. For example, you take a AC. Next slide, ma'am. Ma'am, next slide, ma'am. Yeah, AC, air cooler. In an cooler, here you see, you know very well where you are kept the air cooler machine also in a top. This is also the same reason. If your outside hot air is coming in the inlet nozzle, if it is going inside the tube, then automatically fan is there. Due to the fan, this is comes under forced flow. I already told. Due to the, because of the fan or pump, this hot air becomes cool. It will go in the tube and return header. In the end, one end it is having return headers. So it is written once again. It comes down of the that material, that is outlet headers. Outlet nozzle is there. So whenever it is come in this side, because of the fan, this hot air becomes cool. So once it is cool, you will get the outlet nozzle cool air. This is the concept in an air cooler, that hot air becomes the cool air by using this forced convection, forced fluid flow. Okay. Well, if you are going in a Switzerland, like a very cool area, then the same air cooler idea we are using like a heater. But in that areas, not only in Switzerland, nowadays in Ooty, Kunnur, those areas also they are using this heater concept. This heater they will place in a down of the ground. If you see, then you can understand. They will place in a down of the ground. So what will happen in a down of the ground? They will place the heater same, but cool air goes in the inlet tube. What will happen in a cool air goes in the inlet tube. In the heater, fan won't be there. Okay. So the cool air becomes hot because it is a high dense particles. Already I told you, high dense particles, so automatically it will heated naturally. Okay. So it will come in a written way. So you will get the outside a hot air. Okay, this process only happened in a heater. Ma'am, next one, ma'am. Next is radiator. Radiator is nothing but the same concept. You know very well, whenever when the car is moving in a very high speed, is too much of distance. After sometimes the radiator become too hot, that then we need to make it as a cool. The coolant here, the coolant is nothing but maybe coolant oil, or sometimes we will use water also. Here nowadays modern car and all, they are using aluminum. Why they are using aluminum? Aluminum is a very nice heat transfer. So here one layer, that air fins, that also aluminum fins in modern car you can see. You can get the air fins are also in aluminum. The inlet, the hot air will come due to the aluminum tubes, that coolant tubes, these and all high heat transfer. So automatically this air, this air also a fluid, yes. The inlet of a hot air becomes cool by using the coolant tubes. Automatically you will get outside, because of that cool air. You will get the outlet tube, that is becomes hot air becomes cool. So finally you will get the cool air. So it is the engine temperature will be reduced due to the aluminum. Ma'am, next slide, ma'am. Yeah, magnetohydrodynamics. Hydro means water. Dynamics means motion. When the water is moving in a magnetic field, that is nothing but magnetohydrodynamics. First Faraday did this uh, what experiment, that is in a Thomas river. Both side, one side a positive charge and another side a negative charge he placed, and a magnetic field. In the magnetic field, positive charge and a negative charge, so automatically electric field will happen in the magnetic field. So you will get a electromagnetic force. That force here, electromagnetic wave I shown here. So whenever this electromagnetic force is due to the electromagnetic force, you are getting the electromagnetic wave, which is due to this wave we are getting the fluid motion. So whenever electrically conducting fluid passing through the magnetic field, so that the fluid motion will happen. This type of fluid flow is called as a magnetohydrodynamic fluid flow. It is nowadays too much of helpful in so many equipments, because nowadays we are using each and every modern equipments based on the electromagnetic waves and electromagnetic force. Ma'am, next slide, ma'am. Ma'am, little fast. Yeah, geophysics, ma'am. Next slide, ma'am. The application of geophysics, here you see, here in that geophysics, you see the earth mantle. In that earth mantle, solid inner core and liquid outer core, both two cores are there. Both core having significant quantity of iron. Actually what is happened, in the liquid outer core move in the presence of the magnetic field. Okay, after that it produce the circulation. So due to the circulation, it will develop the magnetic field. So already earth is having a magnetic field. So outside the liquid, it also produce the magnetic field. So both the magnetic field, so this extra magnetic field, it boost up the earth magnetic field. So automatically what will happen, this magnetic field increasing, that is self sustaining. This self sustaining, it will make the flip. There is a small flip due to the magnetic field. There is a small flip happened in the earth. So this like this small flip, it will increase after hundreds and thousand years. There is a, just like that, north side is move in a south, south side will move in the north. This is the reason for the rotation of the earth. So that only the earth is moving, because of this full and full the liquid outer core move, so that magnetic field, using the magnetic field, this dynamic effect is happened. This process of such self-sustaining, this process is called geomagnetic dynamo. This is very very helpful in a geophysics concept, that full and full this fluid dynamics concept is using. Ma'am, next slide, ma'am. Yeah, water metering, for example, a single house or many houses, we are how much amount of water is passing through the house. in the hose, we can find out using the water metering. Similarly, magnetic flow meter, it is used to find out the how much amount of magnetic field is used. Both are based on the electromagnetic field, because they will kept the magnet, and also the electric current is passing. So based with the help of electric current and magnetic field, electromagnetic waves will start, then water will move, then magneto-hydrodynamics, that fluid motion will happen. So based on this concept, we can find out the volume and the amount of water which is moving, or magnetic field, how much magnetic field is moving from one place to another place, we can find out. Ma'am, next one, ma'am. Yeah, radiation, it is also based on the electromagnetic wave, which is electromagnetic waves which is moved from the sun to the earth. So that only we are getting the heat from the sun to our earth. Similarly, from the fire we are getting the electromagnetic wave, so that we, in a cool time, we are using the fire camp. Similarly, in a fire camp we are even fish or food items, uh, we are cooking. And also, for example, microwave also, it is based on the electromagnetic waves. Whenever the microwave, inside the microwave, automatically what happened, surroundings, cool air become hot, so the particles also, particle means food item becomes hot, so that only we can get the hot items. It is fully based on the electromagnetic wave. How you tell it? Because electric current is passing through the microwave, and inside the microwave you are placing a material which is a magnetic one, that is it pass the microparticles. Due to these microparticles, the air becomes hot. So due to the heat of the particles, the food is also become hot. Similarly, barbecue chicken. Actually, this is also the same procedure. The electromagnetic wave is passing, so that the food is become cooked. Whenever we are speaking about the electromagnetic wave, then current is passing. We will put a magnetic chip or a magnetic material inside the system, inside the equipment. So automatically electromagnetic wave is passing. Similarly, at the period, we will put either air or a fluid, that is nothing but either air or a liquid. Based on the system, it will change. So automatically you will get a magneto-hydrodynamic fluid motion. Next one, ma'am. Yeah, electromagnetic radiation, this is most important in a nowadays, in a modern world. Each and everything, it is based on the electromagnetic radiation. For example, power line, we are getting a before that I need to tell non-ionizing and ionizing. Whenever if you are taking a sodium, the outer if you think the outer orbit, one electron is there, it is ready to give that electron, so it is ready to ionize. Like this type of ionizing material, whenever you are giving little force also, it is ready to give the electrons. So these type of for example, sodium, chlorine, these and all will move with high frequency. Whenever it is moving with high frequency, we will get a very very high frequency, so it won't be visible. Even a sound or anything, we can't visible the movement. But at the same time, that rays, that electromagnetic wave rays, it is used to go inside our body, and body particles it will show. That is nothing but our X-ray. Whenever in a X-ray, that ionizing material, it will move in a high frequency, so we can see the beam, like a laser beam. Laser beam also, we are using the material which is ionizing material, so you will get a high frequency radiation. So the electromagnetic radiation is moving very fast, so that is only we are using the projector, laser pen, everything is based on that one only. But if it is a non-ionizing, ma'am, previous slide, 1 minute, ma'am. If you take a non-ionizing material, for example, helium, okay, that helium, this type of particles, it won't ready to give lose the electrons. So automatically, whatever outer force, that is temperature, anything if you give, then also it will move in a very low frequency. It is visible. Whenever it is visible, these frequency waves we can use in your day to day life. So that only in a TV remote, you are sitting in one side, you are putting a channel, then it is changing. Why? What happened? The laser beam, that and the visible waves, that is non-ionizing material is inside, the electric current is passing inside that material, and also magnetic chip is there. So electromagnetic waves is passing through the beam, that light, so that you will get a laser laser light. This what a remote control, and particularly cell phone, after that microwave I already explained, TV, radio waves, and also power lines, these and all comes in non-ionizing. It is not affected too much, but at the same time frequently if you are using, it will affect our body, because it will generate the heat. Too much of heat will increase the our material, our in our body having too much of cells. These cells accelerate, it will accelerate, so that only we are getting the tension. And also our fluid inside our body, blood is moving here and there throughout the body. Now fluid, our blood is nothing but a Newtonian fluid, a non-Newtonian fluid. So what will happen? This blood also, too much of velocity it is moving, then automatically what will happen? It will produce the temperature, it will give affect throughout our body. That is blood circulation in our full what head, inside the head, blood circulation will stop. It will affect our body. So that only we are telling this, even it is a less low frequency, then also we need to use in a proper way. Next slide, ma'am. Ma'am, that I already told, X-rays, laser beam, projector, all are laser. Ma'am, next slide, ma'am. Here for example laser welding, here also the same concept. Two magnetic beam are there, electric current is passed. Here ruby crystal we are using. Ruby crystal, it is nothing but the non-ionizing, sorry ionizing. So high frequency beam will come, but we are putting the lens so that all the frequency it comes together and it goes in a two material. You need to welding, you will send the laser so that both the material is welding is happened. And next one is laser eye surgery. Not only laser eye surgery, all the laser treatment, hair removing, everything we are using nowadays laser treatment only. What will happen? First we will take the anesthetic drop. After that, we will create one flap above the eye. Using the laser, we will send the laser and we will rectify the issue. After rectify the issue, we will close the flap. Then automatically healing, due to the healing, the process will be over. So nowadays laser in our day-to-day life, this this laser treatment nowadays they are using frequently. Ma'am, next slide, ma'am. Yeah. So using all those concepts, you people understand that whenever you are taking any physical problem, that is application point of view problem, first you understand the problem. For example, if you are throwing a stone, what velocity, how much distance the particle is moving, at which point it will reach. So understand the physical problem and identify the variable. What are the variable is there in that problem? Whether velocity occurs or acceleration, whether it is zero or not zero. So first you understand the physical problem. This will be helpful for a new researchers. Whenever you get the idea of fluid dynamics, it is having the abundant application in our day-to-day life, particularly in a modern world. We are using everything but modern things. So based on this idea, you can start your research work. Whenever you are starting your research work, first you understand the physical problem. What is the problem? What type of, whether radiation is there or magnetic field is there or electric field is there. You understand the problem. Based on the problem, you understand what are the variables you need to use. Okay. After that, assumption and approximation. This concept is very important when you are framing the problem. For example, if you are considering the Plutonian fluid, Newtonian fluid, it will obey the Newton's law. If you are considering non-Newtonian fluid, it won't obey the Newton's law. So that also needed. For example, if you are considering conservation of mass can neither be created nor be destroyed. So based on that, you need to create the mass conservation equation and energy equation. Similarly, so based on your assumption, based on the material, based on the system, your approximation and assumptions will be changed. For example, radiation, then you need to use Stephen Boltzmann law. For conduction, you need to use what? Fourier's law. So depending on your laws will be changed. So apply the physical relevant physical law. After using the relevant physical law, frame the differential equation. After framing the differential equation, what you need to do, either you try to find out the analytical solution or either both analytical or numerical solution. Nowadays numerical solution, Rangi-Kutama method, or many methods are then nowadays they are using MATLAB, Mathematica in every C program. C program Fortran and all, it is old version like that. They are thinking Sung Math. These type of mathematical softwares are there. Using that softwares are Rangi-Kuta method, otherwise Hummus method. These method you can apply and solve the problem, and you will get the solution. So after getting the solution, you need to analyze the issue. What is the predict? You need to predict the what will happen, the fluid flow motion. That is only the main application. Ma'am, next slide, ma'am. A little fast. Yeah, this is our Navier-Stokes equation. You know very well. It is based on the either convection. The change in velocity is depending on the either in conduction or convection. Due to diffusion also the velocity will change, and also pressure and force. Ma'am, next slide, ma'am. One-dimensional heat equation. These equations and all needed a Navier-Stokes equation, heat equation, mass equation. Based on all those equation, ma'am, next slide, ma'am. Next slide, ma'am. No issue. Yeah, based on all these equations, first you make a physical problem. After the physical problem, you need to find out the equations. Here I am taking a very basic problem, MHD. I already told magneto-hydrodynamics concept. I already told heat transfer concept. Stretching is nothing but a layer which can be able to stretch. That is called as stretching. For example, plastic. Plastic is a stretching surface. If your skin also is stretching surface. Next, porous. Porous is nothing but a surface which is having a small tiny hole is there in it. For example, our skin is also a porous surface, because after sometimes you can get a sweating. Similarly, the water is you sink. Source and sink, both is happened in a porous surface. That is, the fluid comes out, that is called source. The fluid absorbs the fluid, that is called as a sink. A sponge you can consider, that is also a porous surface. These porous surface will reduce the heat. Why? The fluid particle is moving very fast. At the time, the porous surface, the fluid will vertical motion, fluid motion must be happened. Then automatically the velocity of the fluid will reduce. Then temperature automatically will reduce. In a stretching surface, whenever in a stretching surface, that is plastic, if it is stretched, so the velocity will be increased. Velocity increases means temperature will increase. So based on all those concept, If you take a boundary layer flow, you can find out the equation. After that, you can solve the problem. You will get a graph. In the graph, you can predict what will happen in the fluid motion. This main motivation of this type of problem is, if you take a plastic polymer industry, the final quality of the plastic is depending full and full the heat transfer. That is, heat transfer means the fluid, the material, the density and mass of the material. The density and mass of the material, it is depending on the stretchingness, and magnetic field is magnetohydrodynamics fluid flow. So that what is happened of the fluid velocity. So all this concept comes under this flow. Ma'am, just you can skip, ma'am. Yeah, this motivation, everything I told. Yeah, formulation of the problem I explained. Based on the, I told already, the boundary condition, we will get here. Yeah, graph, 1 minute, ma'am. Here, this is fluid velocity. That is only I told. Whenever suction is increasing, automatically fluid velocity will decrease, because the perpendicular hole is there, so the fluid velocity will be stuck. Whenever you are getting the graph, you can compare the physical laws with that graph. Okay, we are getting a proper reason to explain the graph. Then your method and your answer is correct. So whenever this is correct, then automatically if you change the suction variable, so that in what will happen in the fluid velocity, like that, suction means you are changing the material, what will happen, like that you can predict. So what are basic that you check with your solution and graph. After that, you change the variable, you change the material for a new problem, so that your output will be correct. You can checking by yourself, your error will reduce. Next graph, ma'am. No issue. Yeah, temperature will reduce automatic. I already told. Yeah, all the graph you can skip, ma'am. No issue. Yes, ma'am. Conclusion you can come, ma'am. Ma'am, skip the slides, ma'am. No problem. Ma'am, move the slides, ma'am. Hello, ma'am. Hello. Hello. Yeah, conclusion. So the final point I need to tell, after the graph, after the problem, I find out the effect of porosity is to reduce the velocity and temperature. Yeah, it's correct only. Whenever the porous surface is there, automatically velocity will be reduced. Whenever velocity will reduce, temperature will reduce, skin friction also will reduce. So these I get the points, use the points, I draw the graph. If I change the point, I will get a different graph. Here I am using the Mathematica software. If we can use not only the Mathematica software, MATLAB software also you can use. Rangikuta fourth order method. Nowadays we can. It is a very big, very basic problem. So I used Rangikuta fourth order method. You can use nowadays Rangikuta sixth order, seventh order, like that. Higher order also came in our picture. So similarly, Prandtl number is nothing but the ratio between the internal and viscosity. So you can find out the viscosity, what is happened if you are taking a high viscous fluid. If you change the Prandtl number, you will get the high viscous fluid and low viscous fluid, because the ratio of the moment diffusivity and the thermal diffusivity, it will gives the Prandtl number. Diffusivity depends on the viscosity of the particle. Okay. Similarly, the final output velocity of the less significant when it is porosity is there or not. If you taking the power law velocity is nothing but the velocity of the fluid is directly depending on the fluid motion. Then it is direct proportional. V is directly proportional to x. V equal to x power m. Then it is called as a power law velocity. That is, velocity is power of the material. That m is called the power law constant. Depending on that also, fluid motion will be changed. That's all. So yes, madam. these are some of the references in my problems. After that, yeah, thank you. My point is actually not only in a laser beam. Uh, Nowadays, in our day-to-day life, fluid dynamics having too much of abundant application. I already told. Not only I need to tell in a NASA, ISRO, wherever research center, if you go, there is a fluid dynamics one place. They are starting the research in fluid dynamics because uh, in a racket or when you are going in up, then geophysics, astrophysics, everything, it is based on the fluid dynamics. So they are having in wherever you are going to the research center, you will get the this type of what fluid dynamics basic research they are doing. After that only they are getting the uh, higher more research. So it is having too much of application. Please you try to understand and study. Then only your research will be fruitful and you like to do the research. That is my point. Okay, I think I complete my
Thank you,
talk.
ma'am.
Yeah. Yes, ma'am.
Thank you, ma'am.
Yes, ma'am.
Really, your lecture was very interesting and informative one. I am
Yes,
very
ma'am. Thank
sure
you.
that the participants would have enjoyed and enriched their knowledge in the domain of fluid dynamics. Thank you, ma'am.
Yes, thank you. Thank you. Thank you.
We will go ahead and take some time for questions now. Just a reminder,
Yeah,
please be
in
sure to type
here
your
I
questions into the chat box.
yeah, what are the use of infrared rays is there? Infrared rays, that is only we are using nowadays in a what remote. Remote we are using infrared rays only. It is visible rays. Uh, that UV infrared rays only we are using in a remote. After that, laser therapy used to cure cancer 100% sure. We are using the laser therapy, little 50 percentage they are using, and nowadays they are increasing not only laser treatment for cancer and also what that actually alpha beta gamma rays. I need to tell about these point for telling this answer for this question. Because whenever if you are taking a uranium, okay, if you are taking a uranium, you are placing place in a magnetic field. So what happened, from the uranium you will get a positive charged particles, negative charged particles. After that, the neutron particles, the positive charged particles are called alpha particles, negative charged particles are called gamma particles, and beta particles, these three particles. Actually what will happen, the positive charged particles will move only up to the paper, it won't cross the paper. It is also a radioactive particles, but its energy is very less, but then also it will damage the cell and DNA, this alpha particle. But if you take a beta particle and gamma particle, it will also affect the tissue and also our bone, okay, and also DNA, because it is high energy particle compared to the alpha particles. The beta particles are negative charge particles, gamma particles are it has the pure energy, it is visible light. So it will move fast and it will damage the tissues and DNAs. So what point I want to tell, these type of radioactive particles, this also they are doing some research to cure the cancer. Not only the laser, laser is not a radioactive particle, it is comes from the beam. The this alpha beta gamma particles are the this particle radiation. This they are doing research in both to rectify the issue. Okay, one person is asking microwave cooking. uh, Actually, microwave cooking, you need to understand when you are too much of microwave is coming. Micro means what? 10 power 3. Nano 10 power 9. Okay. What will happen? This microwave particles, due to this we are getting some heat. So automatically, if you are getting a heat because of this particle, and also if you are taking a aluminium vessel, then because of this aluminium vessel, conduction heat transfer will taken. So automatically it will affect the food. So that only they are telling, don't use silver or some conduction material, don't use in a microwave, because too much of heat it will burn the microwave. It will affect the microwave. But anyway, whenever fire is a it is, you know very well, fire you are getting a heat from normally, but in a microwave you are getting a heat by electrically. Electrical heat change is happened. Electrical and magnetic field, due to the electrical magnetic field heat happened, due to that heat the food is heated. So it will affect our body. It is damn sure. Next, any questions, ma'am? I think that's all. Any questions I missed?
Thank you, ma'am.
Which software? I
We
already
have
told.
covered all of our questions,
MATLAB.
ma'am.
Yeah. Which software can be
Yeah.
used? MATLAB, Mathematica software. Nowadays, SungMath. So many R software. We can use any software to draw the graph. Before that, you need to understand whether you are getting the analytical solution. You are going to solve in analytical way or numerical way. After getting the solution, you analyze which method is apt for the problem. That is important. Okay. Yeah. Presentation is so fast. Sorry, actually, because of the current problem issues, I nearly half an hour is wasted, more than half an hour. So I am little fast to complete the my ideas and views. I think you will get a basic knowledge in fluid dynamics, where this fluid dynamics is used in our everyday life. Based on this basic knowledge, now you go and study. For students, you go and study, you will get little more knowledge. For researchers, you go and do the research, then surely it will be helpful to your, whenever you are having a doubt in your research problems, just you can mail me, I will help you. There is no issue. Young researchers do research in fluid dynamics. It is updated research is always helpful, so updation is very very important. Nowadays they are using nanoparticles also in fluid dynamics research, so use those concepts. Okay, I think I answer all
Okay, ma'am.
questions.
Yes, ma'am. Thank you, ma'am.
Yeah, thank you.
Next, I call upon Mr. S. Sanchita, Assistant Professor, to propose her vote of thanks.
Okay.
Good afternoon, everyone. We are at the end of today's webinar. It's my immense pleasure to thank you all at this auspicious occasion. It's my privilege to thank our Honorable Chairman, Dr. K.S. Rangasamy, MJF, and our energetic Vice Chairman, Mr. Raj Srinivasan, and Mrs. Kavita Srinivasan, Executive Directors, who always guide us in all our deeds. I also extend my sincere thanks to our respected principal, Dr. V. Radhakrishnan, for his valuable support. I extend my wholehearted thanks for our dynamic resource person, Dr. M. Kayalvizhi ma'am, for accepting our invitation and for her thought-provoking ideas. And a special thanks to our convener, Mrs. M. Sujata ma'am, Head and Professor of Department of Mathematics PG, and Mrs. Sindhuja, who gave a nice introduction to our resource person. Also, I extend my heartfelt thanks to all the participants. And also, I would like to thank Mr. V. Harikrishnan, Assistant Professor, Department of BCA, for his technical support to conduct the webinar in smooth manner. Last but not least, I would like to thank my colleagues who are all the backbone of this webinar. Once again, I thank you all. Thank you.
Thank you, ma'am. Thanks again for joining us today. and we will see you the next time.
Thank you, ma'am.
Thank you, ma'am. Kavi ma'am, for sharing your
Yeah,
valuable
thank you.
time with us. Thank you very much,
Yeah,
ma'am.
thank you.
We will meet again in another program.
Yeah,
Thank you
sure,
very
ma'am.
much,
Sure,
ma'am.
ma'am. Thank you, ma'am. Sorry for the issues, ma'am.
Okay, ma'am.
Okay,
No
thank you,
problem.
ma'am. Thank you. Yes.
Okay, thank you, ma'am. Dear participants, thank you all. After completing your feedback form, you can leave the meeting. Thank you all once again. Thank you all. Yeah, last step is closing. My special thanks to Jagadish and also Hariharan from Women's College. Thank you, Hari. Thank you, Jagadish. ஆன் பண்ணி வச்சுட்டு போயிட்டாங்களா?
மேம் இருக்கேன்.
ஆடிபிளா இல்லையா இது? யாரோட